All right. So we'll go ahead and get it kicked off. In the past, we've always had a few people kind of rolling in late, so we may get a few more trickling in. But thanks everyone for joining. If this is your first AIAA Space Resources webinar, welcome. And if you've attended the past couple, then welcome back. The idea of this webinar series is to bring space resources, education and outreach to the general public. So this is a series that my fellow Vice Chair Jared and I have put on over the past year. It's a monthly series that is recorded and posted online. So you'll actually be able to see this recording at the AIAA Space Resources YouTube channel, and you can go check out all of our past visitors. So for those of you that don't know me, my name's Joe Kenrick. I actually work for Lunar Outpost at Lunar Outpost Oceania, the Australian branch of Lunar Outpost, who AJ also is a co-founder of actually. But today I'm representing AIAA as the Space Resources Education and Outreach Chair. Our intent is we started with government agencies, NASA in particular, sort of laying the framework and the vision for space resources. And we've been transitioning into commercial companies actually sort of doing the work and executing on that vision. So we have a well-timed presentation today from AJ to get it kicked off. Last note, you'll notice there's a Q&A section at the bottom of your Zoom screen. So you can enter your questions throughout the presentation there. AJ will speak for about 40 or so, and then we'll have 15 to 20 minutes of questions at the end, and I'll read those out in the order that we receive them. So I think we're good to go. I'll hand it off to you, AJ.
All right. Thank you, Joe. So welcome, everyone. As Joe said, my name is AJ Gemmer. I'm the Chief Technology Officer and co-founder of Lunar Outpost. And prior to my time at Lunar Outpost, worked for 8 years at the Laboratory for Atmospheric and Space Physics, particularly within their dust lab, hence my interest in the lunar surface, space resources, and all of the great work that there is to be done in space. So back then, I observed that there were a lot of really mature spaceflight instruments and really great mission concepts out there, but opportunities to fly were few and far between, especially for surface missions like rover missions. And so that was part of the idea coming into co-founding Lunar Outpost, to provide mobility as a service, robotics for extreme environments, both here on Earth and in space, and basically provide more opportunities for space science and commercial space activity to develop. And I'd say over the last 7 years, that has absolutely held true, in particular, beginning of this year with all of these excellent CLIPS launches and the recent successful IM-1 landing on the lunar surface. So it's shaping up to be a great year in the cislunar economy. So with that, I think I'll share my screen and start presenting my slides and tell you a little bit more about what we do here at Lunar Outpost and where we see things going. All right, Joe, can you confirm that you see my slide?
Yep, looks good.
Great, thank you. I'll minimize us here. Okay, so the title of my talk today is Scaling Commercial Lunar Mobility from Exploration, which is the current state of the art, to infrastructure, a key next step in expanding operations on the moon and beyond, and eventually one day to crew rovers in support of NASA's Artemis program. So as a company, Lunar Outpost has a mission of developing advanced mobility, robotics, and systems that enable a sustainable presence both here on Earth and beyond into space. We do this by addressing a couple of key markets. So we started off with a product line that we call Canaries, our air quality monitoring sensors. Those were originally developed to do air quality monitoring within the Lunar Gateway space station prototype. And we spun that out into a terrestrial product, which is now deployed across the United States and the world to do particulate matter and speciated gases monitoring in a wide variety of industrial and commercial applications. Shortly thereafter, we began pursuing both terrestrial and cislunar robotics in parallel, which have many great overlaps with our environmental monitoring side of the business, as well as exciting new applications that I'm sure you can imagine. So we started with this core concept of robotics as a service. That is, like I said, providing mobility to things like instruments, sensors, payloads in the space context. That's an exploration rover that we would call it, but also here on Earth, providing a more industrialized workforce and taking humans out of more hazardous or more tedious job roles. So that's where we began. Moving forward, these robots are being used more heavily in infrastructure, and that means building, inspecting, and maintaining things like energy and communications type infrastructure. That's already well underway here on Earth, particularly in resource, oil, and gas fields. And we also have some prototypes up and running and planned missions for the early stages of lunar infrastructure as well. And of course, all of this enables resource extraction in the future. So in space, that would be in the context of accessing the near infinite resources of space to help improve life here on Earth, alleviate some of the resource scarcity and environmental pressure that comes with resource extraction, as well as complementary efforts in the resource industries on Earth as well, trying to drive resource extraction towards a carbon neutral future. So while these are different environments, they are complementary markets that we can apply similar technologies to. And that's really critical to our success as a company, is finding those key overlaps between all of these different technology and product lines so that we can drive revenue, grow as a company, and continue to expand towards our future vision. A bit of a company timeline. So we were founded in 2017, and shortly thereafter, less than a year, sold our first Canary air quality monitor. So very short time to market. From there, things picked up quickly. We had a number of contracts with the Air Force and NASA, as well as the Space Force, both on the robotics side and on the instrumentation and sensor side. In 2020, our Canary air quality monitors collected their 15 billionth data point, which represented a big milestone for our company in managing, processing, and analyzing those huge data sets that come with continuous air quality monitoring. And the big white box at the top was particularly fun. Towards the end of 2020, Lunar Outpost was awarded a contract from NASA to collect space resources, in this case, raw regolith, and transfer it to NASA in exchange for money. And that was really important because it was the first time that NASA had, contracted a private company to go and do that. And it established a legal precedent that space resources, are a commodity which can be harvested, bought, and sold. And so our total contract value for that was $1, which generated quite a bit of press. Of course, we understood that, it wasn't really about the money. It was about establishing those precedents and legal pathfinders. And so we're very excited to be awarded that contract and plan to fulfill that this year. At the same time, we've been running operations of an instrument called MOXIE aboard the Perseverance rover on Mars, which creates oxygen from the Martian CO2 dominant atmosphere. So another example of resources that can be harvested from the local environments in these planetary environments. In 2023, towards the end of last year, we delivered 2 flight model MAP rovers to their respective customers. And we're planning our first missions to the lunar South Pole this year in 2024 aboard the Intuitive Machines IM-2 lander. So we were very excited with how successful the IM-1 mission went recently. And looking into the future, we want to continue this expansion and this technology flow. And that's what this slide is meant to illustrate, are those pathways and overlaps between the Earth, the Moon, and Mars, as well as orbital and cislunar robotics applications. So really a whole cislunar econosphere. Here on Earth, you can see, we have pictures of the Canary, which is that little white box on the top left, as well as one of our Hound rovers, which is a big several 100-kilogram rover that was recently used to compete in the NASA Break the Ice Challenge. I'll talk a little bit more about that later. On the Moon, we've got MAP as our small exploration rovers. The Hound will be evolved into those infrastructure rovers that I mentioned earlier, setting the pathway for large-scale space resources extraction, as well as crewed mobility vehicles like the Artist concept shown there. And of course, providing more and more cost-effective lunar science return as well. And as part of NASA's Moon to Mars architecture vision, we envision this technology flow benefiting Mars as well, deploying more instruments, developing more science, and eventually looking towards Mars and beyond in the space resources realm. Along with myself, Lunar Outpost is led by our founder and CEO, Justin Cyrus, as well as our Chief Strategy Officer, Dr. Forrest Mayan, and Julian Cyrus, our Chief Operating Officer, and 83 world-class engineers who are helping us build this vision every single day. Of course, shameless plug, we're always looking to add A-plus talent, so if this is exciting and interesting to you, we'd love to hear from you. And this image was pretty cool. This was when NASA Administrator Bill Nelson awarded us that resource collection contract. So Forrest is holding our check for $1 for space resources there. We have 4 facilities now. So our original location in Golden, Colorado, which is now administration, canary assembly, and some testing facilities, as well as a larger facility nearby in Arvada, Colorado. That's where we've got our 30,000 square foot robotics lab, as well as ESD manufacturing electronics labs and autonomy test beds. We also have Lunar Outpost EU, headquartered in Luxembourg City, Luxembourg, where we do a lot of research and development, particularly on thermal technologies. That started with a focus on helping our robotics survive the long, cold lunar nights, and has since found some Earthside applications as well. And as Joe mentioned, our newest outpost in Melbourne, Australia, our Australian headquarters, where we work on the Australian Space Agency Moon to Mars Trailblazer program, as well as some other technologies such as carbon neutral mobility and advanced clean energy technologies. A bit more about our facilities. So we do have a large Class 10,000 or ISO Class 7 clean room where we do our flight assembly of the rovers, as well as payload and instrument integration services and testing. We do a lot of in-house manufacturing. We're highly vertically integrated, so we have large manufacturing facilities, including CNC mills, machine shops, 3D printing, etc., and a number of regolith test beds, a small one at Colorado School of Mines Center for Space Resources, and a larger one in-house at our large facility in Arvada, as well as an outdoor testing facility, which is called the Southern Colorado Autonomous Test Facility. That's about 1,000-acre facility where we can do really long duration drives. So we've driven rovers several kilometers in a single stint out at that facility. And I mentioned the ESD lab spaces for rapid iteration on our electronics, which of course is necessary to deliver these flight model rovers quickly and cost effectively, and 30,000 square foot manufacturing space shown there, where in the background you can see our canary production line. So this is an image from NASA, but I feel like it really illustrates just all of the different robotic capabilities that are going to be needed, starting essentially now, but well into the future for the next several decades. So on the left is, sort of the present day. NASA's looking at things like Gateway and Lunar Terrain Vehicle, moving to crew landing services with Artemis 3 and beyond, eventually looking at things like pressurized rover, fission surface powers, and I think something that we're all very excited about, ISRU pilot production plants. Of course, some of our infrastructure rovers will be key in collecting and delivering raw feedstocks to pilot plants like that. And eventually, long-term surface habitation as well. All of these needs can be significantly augmented and improved by robotic services, both on the orbital aspects as well as the surface aspects. And of course, there are many challenges that are yet to be solved in addressing these needs. So that's really what we focus on doing here at Lunar Outpost. And to give an example of how we're moving the planetary mobility state of the art forward, there have been past rovers which are very capable, very impressive, long-lived, like Perseverance, which has a program cost of almost $3 billion, but a lifespan of nearly 10 years, which is an excellent science return. The next NASA rover to the moon is the Viper rover at about 500 million. Shorter lifespan, but still going to provide some excellent science opportunities. And where we come in is delivering mobility capabilities much faster than has ever been done before and much more cost effectively as well. So, our little map rovers shown at the bottom right there can be deployed, orders of magnitude cheaper and more cost effectively than has ever been possible before. And I'll talk about some of our upcoming missions and how those capabilities are already being leveraged both by NASA, government, and commercial customers. So as I mentioned, we're beginning our regular lunar missions this year. The first one is to Shackleton Ridge aboard the Intuitive Machines IM-2 mission. So given that recent IM-1 success, we are ready to go there, and that flight model rover is already delivered. Same with our mission 2, which is to Reiner Gamma, a near equatorial site. That one's carrying a NASA instrument payload. Mission 3 is fully commercial. So a number of commercial companies interested in deploying their payloads and technology demonstrations to the moon there. And finally, the Australian Space Agency Trailblazer mission projected to launch in 2026. So if you had asked me back in, say, 2018, if I thought our first mission would be NASA funded or commercial, I would have said, well, probably NASA funded. I think the industry will need some help getting going. But that's actually not what happened. Our first mission is fully commercially funded with Nokia as our anchor payload customer, demonstrating their LTE communications technology at the South Pole of the moon. As I mentioned, that one's launching aboard Intuitive Machines lander, lifted off by a SpaceX rocket. So that is slated to make MAP, our Lunar Voyage 1 MAP, the first rover on the lunar South Pole this year. So I'm very excited to get that mission up and going. And renderings are nice, but I'm a hardware guy. I always prefer to see some pictures. So here's some photos of the actual flight model during testing. On the left, we did extensive testing on safely deploying from the Intuitive Machines Nova C lander, and that's what you see there. And on the right is kind of the glamour shot of the fully built flight model rover as it was delivered. I mentioned the second mission, Lunar Voyage 2, which is headed to Reiner Gamma, also slated for 2024. This one was through the NASA PRISM program, and it's actually the PRISM 1A mission, the first of the PRISM missions, which is envisioned as an ongoing series of science missions delivering these cost-effective science investigations to the lunar surface. In the case of this mission, which is called Lunar Vertex, it carries two instruments. One is a multispectral microscope looking down at the regolith and characterizing its chemical composition. And the other is a vector magnetometer, which is that mast you see on the top of the rover. And that's why Reiner Gamma is scientifically interesting. It has these light and dark swirl patterns in the regolith, which are caused by a local magnetic field, but the source and characterization of that magnetic field has yet to be done. So really looking forward to supporting and providing mobility there. What's interesting is you may have noticed on the previous slide, the Lunar Voyage 1 MAP rover has fixed solar panels on the sides of the rovers. That's because at the lunar South Pole, the sun will be very low in the lunar sky, and we want to keep the incoming solar illumination roughly normal to our solar panels. Whereas for an equatorial mission like Lunar Vertex here, we deploy the solar panels to a near horizontal position to take advantage of that equatorial sun high up in the lunar sky. And again, some great pictures of the flight model hardware. So on the left, that is the Lunar Vertex map at JHU APL being displayed, and I believe it's set up on the vibe table there, and the flight model on the right-hand side. For each of these rovers, we do a program where we build both an engineering model, which serves as a flight spare. It is a fully flight-ready rover, as well as the flight model itself. So that brings us to a total of 4 MAP 3 vehicles currently in production, 2 of them already delivered. I mentioned Lunar Voyage 3. Again, this is back to a fully commercial architecture. So we have a number of payload customers who want to demonstrate and validate their technology, often desiring to be the first to a specific location on the moon. So this is what our Lunar Voyage 3 rover looks like. And we do still have payload space available here as well. So if there's something that you'd be interested in driving around on the lunar surface, we're always interested to hear from you. And finally, the Australian Space Agency Moon to Mars Trailblazer program, where a main focus of this mission is collecting space resources from a variety of sample sites and delivering them to a NASA-provided regolith processing facility. So that's what the notional scoop is on this rover here. If you noticed, Joe's background actually at the beginning of this talk had some images, I think, of a higher fidelity version of what that rover is likely to look like. And so I mentioned early on, that it's an important part of our company to find overlaps between all of our different technologies. So with all of these rovers that just mentioned, the spaceflight rovers, as well as our Earth robotics and even Canaries, we've spent a lot of time and put a lot of effort into developing our controls and interfaces that can be used across that entire product line. And we call that Stargate. So that's what provides our mission control solution for all these different robotics. This provides services for things like command and control of the spacecraft and the rover flight systems, as well as software-based payloads, instruments, telemetry, payload systems, and science observations. It makes it very easy for customers to get onboarded and integrated in our rovers. It's really a plug-and-play approach to integrating those payloads. And it provides support even beginning in the early stages with the engineering models and throughout instrument and payload integration and test, as well as integration aboard the landers. It is, very secure by design, serves all of our missions, and every payload customer gets a unique login where they can view their instrument science data and telemetry. So that's the state of the art where we are right now, but I certainly want to take some time to talk about where we're going, what we envision for future programs, and collaborative, sustainable architectures between Lunar Outpost, commercial industry, NASA, and other government. So I mentioned the Break the Ice Challenge. This was a really cool NASA initiative that focuses on scaling up these resource operations. So moving from the early days of prospecting with small instruments to actually moving large amounts of bulk regolith and perhaps one day finished ISRU products as well. So the goal of this challenge was to basically create a lunar concrete, which simulated icy regolith and its properties, lay a big pad of that, and then use robotic solutions to break it up, transport it to a collection site some distance away. And this was done. So Lunar Outpost rovers, we had 2 of these hounds, broke up and transported 12 metric tons of that lunar simulant to a simulated NASA processing facility over a span of 15 days. Did about 800 kilograms of that per day and had to drive it and deliver it 500 meters from that site. So we successfully completed that challenge and were named a finalist in the Break the Ice Challenge, and we'll be heading down to Kennedy Space Center in a few months for the finals of that. And all of this is in support of, our vision of large-scale commercial space resources. So we are working on spaceflight versions of these rovers as well to support commercial missions starting in 2026. I mentioned infrastructure. Here we have an artist's conception of a larger rover about the scale of those hounds, working collaboratively with an astronaut to lay this pad, which could represent a roadway or a landing pad, something like that. But there will be a lot of infrastructure construction in the early days of the cislunar economy. So things like power and comms cable laying and connecting up systems. Like I said, building launch pads, roadways, blast berms, foundations, that sort of thing. And so we are adding capabilities to our rovers all the time to support that, things like robotic manipulators and other infrastructure, construction, and maintenance related tasks and implements. Looking even further towards the future, this is our concept for Lunar Outpost Hippo, which is a 1,000-kilogram resource harvesting rover. And this really speaks to what I mentioned at the beginning of the presentation, accessing those, nearly infinite space resources and improving life here on Earth by, offloading some of that to a space environment. So Lunar Outpost is a key supplier of, accessible and reliable extraction robotics and technologies. And even in the first few inches of lunar regolith, there's tons and tons of critical minerals, from water ice to rare earth elements, metals, all sorts of interesting species to be extracted there. And as I mentioned, this will have to build on the infrastructure activities that come before and are also benefited by robotics. And finally, looking towards Artemis 3 and beyond, future astronauts' habitats will require mobility and robotics as well. All of it needs to be very well developed, very safe, in order to interact with human astronauts. But if we, as a species, want to have people on the moon, living continuously, then this is the path to doing that. And so NASA has solicited the Lunar Terrain Vehicle Services Program, and Lunar Outpost is excited to be working on these types of challenges as well. So looking even further out into human-rated mobility and on to Mars. So last year, we achieved a number of really critical milestones, things like delivering those flight model rovers, performing a commercial pilot of that Hound terrestrial robot that you saw, scaling up our manufacturing line for the Canary air quality sensors, and being awarded the phase one for Australia's Trailblazer program. We're looking towards a big year this year as well. I already mentioned, our first mission operations, capturing contracts as a principal contractor there, scaling up our terrestrial robots even further in the oil and gas and mining industries, and starting to leverage more of cooperative robotics and swarm capabilities. Again, that really yields a lot of benefits for infrastructure construction and maintenance if we can have specialized different types of rovers working together. And finally, to demonstrate evolved capabilities. So bring larger, more capable rovers to bear on these next generation heavy industry applications. So with that, I'd love to open it up to questions. I'll go ahead and stop screen sharing so you can see me.
Awesome. Thank you, AJ. Very informative, very insightful. It's great to see, kind of behind the curtain of what's going on with Lunar Outpost and the execution of some of the vision that NASA has laid out there. So really exciting. So I'll start reading off the questions. Again, everyone, please be sure to enter them into the Q&A, and I will start reading them out. So we got a first one here. Will your upcoming rover survive the lunar night? Do you plan to hibernate or operate?
Good question. So from the early days, we knew that trying to survive the lunar night was going to be a big challenge. And even that first mission does include some technologies and some strategies for attempting to hibernate. Still, we didn't advertise that as a promised capability. I will say, though, with some of the events of this year, like the JAXA Slim lander, it did survive the lunar night and sort of, I think somewhat unexpectedly woke back up the next morning. And so now on the Intuitive Machines IM1 press conference yesterday, they mentioned that they were going to attempt to hibernation and wake up as well. And so we will certainly attempt it. I mean, obviously, it's a huge deal if these initial robotics and landers can survive multiple lunar nights. On mission 2, we have a more advanced thermal control system. So I think it's likely that we'll see night survival there. But really, Lunar Voyage 3 is the first one where we're carrying, dedicated systems and technologies to ensure lunar night survival. And that will really be informed by a lot of that key data that we gather on Lunar Voyages 1 and 2, as well as, what happens with these CLPS landers. I mean, it's very encouraging to see some things starting to survive lunar nights.
Nice. Thank you, AJ. Again, keep those questions coming. Selfishly, I got one while we have a couple more coming in. What do you think NASA's role will be moving forward? As you outlaid, this is becoming increasingly commercial in public and private companies.
Yeah, I think it's really those key public-private partnerships and NASA as providing the vision. I mean, that's why I included and why I love that vision slide. When it comes to establishing habitats and sending astronauts up, I think that really will be largely in the realm of NASA, to kick off and really get those missions going. I would love to see that become a commercial activity with space tourism. I mean, I myself would love to go to the moon if that's ever possible. And then, of course, expanding out beyond that, to Mars and into deep space, and continuing those, science missions that provide the inspiration for next generations. I know myself, was heavily inspired as a kid by all of the cool discoveries that NASA makes. And so I think we'll always be looking to NASA to keep those coming, keep the next generations interested, and hopefully they'll be developing the next generation of commercial space companies.
Absolutely. Good vision. I agree. So let's see, you got a couple more questions from the attendees. Did IM1 utilize your Stargate mission control solutions? If not, do you have a planned test for this software?
IM1 did not utilize Stargate. We did not have a rover on board that. So Stargate was really initially developed as our control interface for rovers and robotics. So it will be used on IM2 and going forward into the future. As far as testing, we've already done a ton of testing. Actually, just a few weeks ago, completed this really cool test where we called it like a day in the life rover operations test. When we're actually on the lunar surface, we will only have the camera views and telemetry that are available from the rover's onboard sensors. So it's really not fair to test rovers or Stargate in an environment where you can see the rover, where you have a third person view, can walk around and kind of inspect the ground around it, et cetera. So what we did is we set up these 10-foot high black plastic curtains around our large test bed, set up mission operations center in another room that was far away from the test bed, and introduced artificial comms delays between the mission operations center and the test bed to try to really accurately simulate what it will be like controlling that rover on mission. And we also did very accurate lunar lighting to simulate the South Pole. So we had the lights right down near the horizon. And then started off a mission exactly as we would on the lunar surface. So inside of a box, which is the thermal garage that map is delivered to the surface in. Map comes out of the box, and you don't initially know your starting position. So you need to first perform checkouts and localization activities and figure out where you are, gather some of that initial imagery to sort of orient yourself in space. And then we had an objective, which was to navigate around obstacles like big rocks and large and small craters, and perhaps like image or photograph, a target of interest that was on the far side of the test bed. So we had to complete all the navigation steps there. And that was an excellent test of Stargate. I mean, like I said, you only get your telemetry that Stargate is set up to downlink and display in a human readable fashion. And because we're trying to complete as much as we can in a single lunar day, you really have to keep that cadence up. There's not a lot of time for hemming and hawing and debating what the telemetry means. It needs to be easy and quick for people to interpret it, and make operational decisions based on that. So that was an excellent test of Stargate. And in another test that I mentioned out at the autonomous test facility, drove the rover several kilometers, again, using Stargate and only the onboard telemetry that we had there. So there are a lot of Earth analogs that we can do, but really looking forward to validating it, for the first time on the lunar surface.
Excellent. See, keep the questions coming. We got a few more here. What types of lunar infrastructure will be beneficial to you in the near term? What is your opinion on the best way to implement this infrastructure? NASA funded, commercial paid services, hybrid approach, something different?
Yeah, to answer the second part first, I definitely think a hybrid approach is necessary. Um, you know, Personally, I think bulk regolith infrastructure is a really great starting point. So, what can you do without a lot of refinement or beneficiation activities? I mean, I'm certainly fascinated by all of the ISRU technologies and concepts that are being put out there, but in the early days, I think it's things like grading and compacting landing sites, especially if we're going to land large, heavy landers there safely with humans on board. Roadways to get from that landing site to wherever it is you need to go, if that's a habitat or a interesting science site or resource site. And then some of the things, actually, I was fascinated by the pictures downlinked by the IM1 lander of right as they came down, the regolith shooting out to the sides, being blown around by the main engines. And I think that speaks to the need for things like blast berms to deflect, all of that so that any hardware or people that you have nearby aren't getting sandblasted by every next landing. So that's what I view the early days of infrastructure being. Of course, hooking up things like power and communications. I think here on Earth, it's easy to take for granted that we kind of always have GPS and often good quality access to electrical power grids and space-based communications, but certainly not the case on the moon. All of that has to be either set up in advance or brought with you. And that's where I think there's a lot of opportunity for commercial actors to set up that infrastructure as well.
It's excellent. Nice. Rolling into the next one. What types of sustainability measures are you investigating for end-of-life procedures of your rovers?
For end of life on the space rovers. So, like I said, for the first two missions, we are going to attempt hibernation and survival lunar night survival strategies. Those range from going into sort of a quiescent low power mode and orienting the rover so that it's optimally positioned for warming and generating power when it wakes back up. And that's really what the end of life for those early missions will look like is just trying to make it through the lunar night and preparing to continue moving. But once we have that problem cracked, surviving the lunar night reliably, we envision multi-year operations of these rovers. So, with any luck, end of life will come much later after they've added a lot of value to these lunar science and commercial sites.
Nice. I'm pretty excited for that capability to be unlocked for not just Lunar Outpost, but the whole, cislunar economy that really opens up the moon.
Absolutely.
Nice. Next question. How is the path envisioned for the transition from in situ manufacturing, and how does Lunar Outpost growth strategy fit in this vision?
Okay. So actually, this was something that I started off in the very early days really passionate about was in space manufacturing. So I'm really looking forward to when we can get some of these regolith processing and manufacturing plants and technologies up to the moon and operating. Like I said, I think the earlier step is the robotics to collect and deliver just the raw feedstocks to them. That's where we focused early on, are sort of these earth moving and infrastructure and construction robots. But there are so many cool things you can do with in situ manufacturing if you don't have to bring all of that mass and launch all of that mass and endure the harsh launch loads by building things in situ. We can achieve big structures, things like there are some really cool radio telescope concepts out there and some of the habitat designs as well. So I think that's what I view as the future of in-space manufacturing, particularly, lunar manufacturing. And of course, there's a whole conversation around water extraction on the lunar surface and, the potential to use that as a refueling depot for missions onto Mars and deep space as well.
Interesting. All right. While we're waiting for some more questions to come in, I've got a few. So
Sure.
there's obviously a lot of interest in the poles, particularly the South Pole, presumably because of the water. But do you think there will be much activity at the equators moving forward, or will it just kind of be confined to the poles?
No, I think there was much to be learned over the entire lunar surface. The poles, of course, are of interest, due to water, like we talked about. But for instance, that Reiner Gamma mission, Lunar Vertex. I mean, nobody knows what the real source of those light and dark regolith swirls are. And so I think these early missions will make some huge discoveries that kind of redefine what's even going on at those near equatorial sites, and I think that will spur loads of interest in future activities as well. They may have commercial interests as well that might drive some sort of resource distribution pattern or accessibility. So I think the entire lunar surface is of great interest.
Nice. I'd like to see outposts all around the
Yeah.
surface. It'd be awesome. I have another one. So now that we're getting some initial landers on the moon, soon we'll have some rovers demonstrating the capability, sort of end-to-end tech, and starting to generate some of that value and starting to look to scale it on Earth, like the Break the Ice rovers you had. But now, kind of moving forward, what do you see as the biggest challenge in scaling operations actually on the moon?
Biggest challenge in scaling operations. Well, not too long ago, I would have said night survival, and that's still a big part of it. But I think it's upmass launch capability. So we're fortunate that we're seeing these trends like dramatic reductions in launch costs, which are enabling things like these CLIPS landers. We see some pretty promising early launches of Starship as well, which is going to have tremendous launch mass capabilities. But yeah, getting bigger, more complex, heavier, longer lived hardware up there to the moon. And like I said, right now, if you want to do a big structure, you have to fold it up, package it up into a rocket fairing. But it looks like that constraint will be alleviated soon, both by enormous launch vehicles as well as in-space manufacturing and assembly. So looking forward to, giant constructions becoming enabled as well.
Yeah, it's pretty exciting. I'm waiting for the next Starship launch, and I think New Glenn is what supposed to launch this year too.
Yep.
It'll be definitely exciting times. All right, we got another question coming in. Can you tell us more about your regolith return missions? What is the process? How are you sealing the samples? Just hoping for soil, or will the samples be hermetically sealed?
So I presume you're referring to what I mentioned, that NASA regolith resource collection contract. That one actually never gets returned to Earth. So our rover picks it up. We do some science characterization on it, density and imagery and things like that. And then what it calls for is an in-place transfer of ownership. So basically, it is transferred from Lunar Outpost to NASA via a legal mechanism here on Earth. And the physical sample itself is then NASA's to do what they like. If they'd like to go and recover it or pick up the rover someday, they're certainly welcome to do that. But it won't be sealed or lifted back up off the lunar surface. And so, with our robotics capabilities, that's really what we're focused on is what can we find there and how can we use it in situ. Still, as a scientist at heart, I absolutely support concepts to return more lunar material to Earth for detailed scientific analysis as well. So I do hope we'll see those capabilities coming online very shortly.
Yeah, this in-place transfer is really intriguing and interesting to me. Um, do you have some additional thoughts on like the legal considerations of that and how may sort of support that?
Yeah, absolutely, and that's why we got involved with it in the first place. Was there's been a lot of talk about space resources for years and years, even back before we started Lunar Outpost, and it was clear that there needed to be some sort of impetus to really codify and formalize these types of concepts, these legal and policy pathfinders. And so when we saw this one come across the regolith collection contract, and we saw that it had a relatively low, dollar amount attached to it, it was immediately clear that this was a move to, put those legal pathways into practice and to the test. And of course, we wanted to be a part of that. It's just super exciting. So I think there's a lot yet to be worked out and discussed. But we've had decades to do that, and it has progressed relatively slowly. So I'm very much in favor of things like our regolith collection contract to be a forcing function and make these conversations happen, move them along, and find agreed upon legal regimes that allow commercial and government actors to utilize and leverage space resources without conflict or negative repercussions.
Yeah, absolutely. Well, continuing on that theme, got a tough one. What are the legal pathways to claiming areas of the moon for permanent bases?
Well, that's not one that I claim to have figured out myself, and I don't think anyone really has rock solid uh, standing to do that yet. Like I say, I think it's going to take these early operations, people actually going up, doing it, perhaps creating or deriving value from an area to force those conversations and agreements to be made. So I know there are a lot of different schools of thought on this, but I think we will see some major movement on these in the next few years.
Yep. Nice. Another one here. How do you see the road infrastructure unfolding in the future?
That's a good question. I've always been fascinated by the concept of like lunar civil engineering. Here on Earth, we have very well-defined design tools, analysis tools, construction methods, et cetera, for building, very robust, very long life roadways. But that really doesn't exist for the moon. And, regolith, I mean, like I said, coming out of the dust lab at LASP, regolith is pretty weird. It's non-intuitive to us here on Earth who are used to dealing with, sands and sort of terrestrial building materials. So I think that is really an emerging field, that of extraterrestrial civil engineering. How do you first design a roadway, say what you want to build, and then once you've built it, how do you verify that you actually met those parameters? Things like compaction and have used your construction materials in the correct and safe and most effective way. And so the question was, how do I envision that evolving? Well, I think, that's our first step, is to do some of these early constructions and verify that we did indeed meet our design intent and criteria, evaluate things like wear rates, dust lofting as vehicles travel over them, and then refine them and sort of develop and evolve this new science of civil engineering in space so that, in say 10 years or so, we can plan out roadways with the same efficiency and same confidence levels that you can here on Earth.
Yeah, absolutely. A lot of challenges across the board, but it's exciting.
Yeah.
Nice. Keep those questions coming. Just got about 10 minutes left if we have some more. While we wait for some more to come in, I I've always got questions for you, AJ. So there's a lot
Sure.
going on at Lunar Outpost that you outlined. It's maybe hard to choose just one, but what are you most excited about that's coming up?
Oh, that is hard to choose just one. I don't know if I can choose just one, so let me give a few. I am excited to see if the IM-1 lander survives the lunar night. Like I said, that was so encouraging on the JAXA lander that it made it. I would not have expected it, I don't think so. If we can show that, the current state of the art of some of these spaceflight electronics, power systems, etc., are sufficient to survive the lunar night as they sit, I mean, then we're just ready to go for these long duration missions. So super excited for that. Of course, super excited for our first mission. I think, I have long said that on these very first missions, every meter we will find something that we didn't expect. And that could be a good thing, like a cool scientific discovery, could be a challenge, like rovers getting, stuck more easily than we initially expected. But no matter what, these missions are going to rewrite our understanding of, the lunar environment, the lunar surface, dust, regolith, resources. I mean, we as a community are going to learn so much in the next year, even, but 5 years, 10 years, what have you. I mean, there are lifetimes worth of work and science to be done here. So just super excited for these, the books to be rewritten on what the moon is.
Yeah, absolutely. All right, we got a couple questions coming in now. How does the Cislunar product line support lunar surface operations?
Good question. So I already mentioned like in space manufacturing and then assembly of large scale structures. Of course, we need orbital infrastructure, things like a lunar GPS for accurate positioning and location, position navigation, and timing. Lunar communications. Actually, that was a huge takeaway from IM-1 as well. They have an excellent communication architecture figured out, but it was threatened by the fact that some of the dishes here on Earth were large and were affected by relatively low wind speeds. 10 to 15 miles an hour was enough to cause these dishes to have to shut down for safety reasons. And that meant valuable hours lost on the mission. So, as we move forward, improving the reliability, the robustness, the depth of coverage of these types of communication systems certainly has, cislunar orbital components. And then, power, it has long been understood that these large scale operations on the moon are going to require just a massive amount of electrical power. We've got excellent sunlight and illumination, but there are challenges to be figured out there. So, there are orbital power concepts as well that I think have a lot of interesting benefits to cislunar and space resources development.
Yeah, absolutely. All right. Next one. What are the challenges you are confronting when hardening your equipment for longer term projects?
Yeah, that's a good one. It starts here on Earth. Access to radiation test facilities that, they exist, but they are specialized, expensive, and book way out. So again, we're trying to deliver these robotics on unprecedented short timelines and very cost-effective budgets. And that can be at odds with the state of radiation hardened and radiation tolerant electronics. Fortunately, we've been able to bring some of that capability in-house, and also even the commercial market is evolving to supply a good number of key rad hard or rad tall components that we can leverage in our designs. But still, as I mentioned, we're looking towards these long lifespans, years, maybe even a decade on the lunar surface, which will absolutely require just the absolute best in radiation hardened electronics.
Excellent. All right. A lot of great questions that have come through. Thank you to all the attendees. Um, don't have any left in the queue. We'll give it another minute. If nothing else, we can end, but only got a couple minutes left anyways. Oh, here comes one. What type of cooperation or competition do you anticipate between all of the space agencies and commercial companies that are now sending um, mission to the moon, having missions on the moon?
Hmm. That's a good one. Well, on the cooperation front between space agencies, I think there are already, excellent models for highly collaborative space architectures. Examples being, of course, the International Space Station. So I do think, those cooperative capabilities are important for extending out into cislunar space, the lunar surface, and providing, access and scientific knowledge to everyone around the world. And again, great cooperation between Australian Space Agency and NASA and many other space agencies. And I'm particularly excited. Some of my favorite panels at conferences are things like the emerging space agency panels and sessions. It's just awesome to see, more and more countries and people being able to get involved in space exploration and space science. So I think that's kind of one of those things that is enabled by more cost effective and more rapid access to space. Just more people get to participate in all of the cool science and activities that are going on. So that handles the cooperation between space agencies. Between commercial companies, I think it's good to have a healthy amount of competition. It drives innovation, keeps things moving quickly. And so I would say I appreciate a good competition. Take, for example, the Break the Ice challenge. It's good. It's fun to be pushed and see, just what can be done in our lifetimes. I mean, space is so huge. No matter what we all do, there will be more cool discoveries to be made and challenges to be overcome. So I like the challenge presented by space exploration itself, as well as competition from other commercial entities.
Excellent. All right. Another question similar to the one before, but I think a little broader this time. Are there any plans to bring resources back to Earth from the moon?
Well, there are. I've heard of a number of different concepts for that, and that ranges a lot of times for things like rare earth elements that can be packaged compactly and returned to Earth. Also, some really interesting concepts for moving like lunar derived water or fuel from the lunar surface back to, say, Geo or even Leo, and performing refueling operations there. Still excellent advantages to doing that, and once you've already lifted off out of Earth's gravity well. So all of these things are going to be reliant on the robots that extract the resources, package them up, lift them off, bring them back to orbit, transfer them between vehicles. Obviously, like fuel transfer is a huge problem and something that a lot of people are working on diligently right now. So I think it's again just an area ripe for technology development and demonstration.
It's excellent. Are let's see, any other new lunar technological innovations which excite you? Personally interested in maglev roads, commingled power, data and comms laser, and nuclear power.
Yeah, I mean, in short, all of those are super cool. I am really looking forward to technologies that enable us to explore these PSRs and lava tubes. I mean, they're just, there's so lava tubes in particular, super hard to access with any sort of orbital sensing, and so you have to get there, go down into there, and just see what's going on in them. So that's going to require many of those technologies that were mentioned there. PSRs a little bit, easier to explore remotely, but still we're going to need capabilities to get down there on the ground in those dark, very very cold areas, and just understand what it is that's down in there. Is it a water ice frost on top of regolith, or is it meters deep, high concentration ice? We don't really know. And so that's going to require things like power beaming and laser comms. Laser comms is cool to get really high frame rate, high resolution video back from the moon. So looking forward to that as well.
Awesome. See, we got another question, but in total, we probably have time for just one or two more. So get your last questions in. But how will your plans on the moon affect plans to get to Mars?
Ah, good question also. The moon is it's a convenient test bed, and in many ways it's a harsher environment than the Martian environment, particularly with the duration of lunar nights. So I've always felt that it made sense to involve lunar operations in any sort of Martian exploration strategy. The moon is relatively, in space terms, nearby. We can get much more data back more quickly, and again, higher frame rate video, pictures, higher resolution, things like that. So that's how I view. I mean, the moon is its own really cool environment for space resources, but it's also just an ideal test bed. It's so hard to replicate the lunar environment here on Earth now that the cost of launch and landing is coming down and more opportunities are presenting themselves. Let's test it out there. Let's actually test it in the lunar environment. And then I think that will inform our strategies for bringing that technology onto Mars, so that when we actually expend all the time and cost and energy to get things to Mars, we have really good, long duration, high quality operations there.
Nice. That'll be exciting. Excellent. Well, I'll probably wrap it up then in the last couple of minutes. So thanks everyone for joining and all the great questions. Went through a lot. And obviously, of course, thank you so much, AJ, for the great presentation and letting the audience pick your brain for a while there. It's always great to hear a lot of people's insights. Reminder to everyone, this presentation will be recorded. If you want to see the presentation again, go to AIAA Space Resources YouTube channel. You can also check out all the previous ones. This is a monthly thing we do, so we'll have another one end of March. So stay tuned for the exact details and presenter. We'll share that once we get that locked down. But thanks again, AJ. Any final comments from you?
Well, thank you, Joe and team, for organizing it. This is always exciting. It's these AIAA webinars are part of my inspiration for everything that we do here. So keep up the good work.
Awesome. Thanks, AJ. Have a good rest of your day. Thanks,
All
all.
right. Thanks. Thanks all.